So good day everyone. So for today's video, I'm gonna share with you about my report, which is all about the Spearman raw computation between the weight or Rx and the length or Ry of the watermelons planted in a wide range of soil with fertilizers. So for our first column here, we have the watermelons, the number of watermelons, and we have 15 watermelons. For our next column, we have here the X or the weight, and next we have here the Y or our length in centimeters. And for the next column, we have here the ranks, the Rx or the rank of X and the rank of Y, or the rank of length and the rank of weight. And for the next column, we have here the differences. The D stands for differences and D squared or the differences squared. For the column of X and Y or the column of weight in kilos and length in centimeter, I have given here the datas, or I have given here each watermelons their weight in kilos and their length in centimeter. As you can see there, we have 15 watermelons and 15 weight in every watermelons in kilos and 15 length in every watermelons in centimeter. For the next column, as you can see there, we need to rank each weight in kilos. So as you can see there, Rx, or we need to rank the weight. You just need to arrange or organize the weight in ascending order or descending order from 1 to 15. So for the next one, we have to rank the Y or the length in centimeter of the watermelon. So we are going to arrange or organize the numbers from the smallest to highest number. So you're just going to put rank 1, rank 2, rank 3 until rank 15. So for our next column, we have here the differences, or we are going to determine the differences of the ranks between the weight or the X and the Y or the length. So for our differences, for example, for our watermelon 1, we have the 110 kilos and 20 centimeter in height. So for Rx, or the rank of watermelon 1 in weight, is 15, and the rank of length and centimeter of watermelon 1 is 14.5. So if you are confused about 14.5, it's just because that watermelon 1 and watermelon 8 has the same length, which is the 20 centimeter. So we need to put 14.5 of both watermelons for watermelon 1 and watermelon 8. The next one, so 14 and 14.5 and 15, so the difference between them is 0.5. Okay, 0.5. So that's how you are going to determine the differences. So for the next one, for the watermelon 2, we have 8 as Rx and 12 in Ry. So the differences between 8 and 12 is 4. The next one, for the watermelon 3, as you can see, 3.5 and 5.5. So its difference is 2. So the next one, the watermelon 4, is 1 as Rx and 7 as Ry. So their differences, or their difference, is 6. For watermelon 5, we have 9 as Rx and 8 are as Ry. So its differences, or difference, or their difference, is only 1. Next, for the watermelon 6, we have 14 as Rx and 11 as Ry. So their difference is 3. So for watermelon 7, we have 3.5 as our X and 5.5 as our Y, and still we have the difference between them of 2. The next one, we have the watermelon 8, 13 as our X and 14.5 as our Y, and their difference is 1.5. The next one is watermelon 9. For the RX, we have 11.5 and 10 as our RY. So their difference is 1.5 still. And for the watermelon 10, we have 11.5 as RX and 9 as our RY. So their difference is 2.5. And the next one, we have watermelon 11. 7 as our RX and 2 as our RY. So their difference is 5. And the next one, we have watermelon 12. R5 is RX. 3 as our RY, and that is why their difference is 2. And for the watermelon 13, we have here 6. And for our watermelon 13, 6 is our RX and 4 as our Y, and their difference is 2. For our watermelon 14, we have 2 as our RX and 1 as our RY, and their difference is 1. And for our last watermelon 15, 10 is our RX and 13 is our RY, so their difference is 3. So for the next column under the differences, or the D squared, we are just going to square the difference, or the D. So 0.5 squared, so it's 0.25. 4 squared is 16. 2 squared is 4. 6 squared is 36. 1 squared is still 1. 3 squared is 9. 2 squared is 4. 1.5 squared is 2.25. 1.5 squared is still 2.25. 2.5 squared is 6.25. 5 squared is 25. 2 squared is 4. And 2 squared is still 4, and 1 squared is 1, and 3 squared is 9. So for the total, we need to sum up, or we need to add the D squared from watermelon 1 up to watermelon 15. So we have here the total of 124. So let's go to our next tables here. As you can see, we have the temporary and final ranks of weight, or our X, and temporary and final ranks of length, or our Y. So as you can see, for our first table, we have the temporary and final ranks of weight, or our X. For our weight in kilos, okay, so the first column is weight in kilos. Next one is the temporary rank, and the final column, and the next column is the final rank. So in temporary rank, we are just going to put 1 up to 15. So that is the number of our watermelons. And then for our weight in kilos, we are just going to put the kilos of each watermelons from the highest kilos up to the smallest kilos, which is 110 kilos, and our highest kilos is the 280 kilos. So for our final rank, as you can see their difference. So for 280 kilos, the temporary rank is 1, and the final rank is 1 also. And for 230 kilos, as you can see, we have the temporary rank of 2 and the final rank of 2. And for the 220 kilos, we have the temporary rank of 3 and the final rank of 3.5. And for the next one, we have still 220 kilos and 4 as our temporary rank, and 3.5 as our final rank. So temporary rank and final rank has a difference since our weight in kilos, since 220 kilos has the same kilos for both a watermelon, so we need to put as our final rank the 3.5 for both watermelons, and so on and so forth. Next table, we have the temporary and final ranks of length, or our Y. So same as with the first table from our weight. So for the first column, we have the length in centimeter, the temporary rank, and the final rank. So same as with the first table, for the temporary rank, we need to put 1 up to 15, which is the number of our watermelons. And for our length in centimeter, we have the highest length of 47 and the lowest length of 20. So for 47 centimeter as our ranked 1, and still that is our final rank since 47 centimeter is just only 1. Next is 45 centimeter. We have the temporary rank of 2 and the final rank of 2. Next one, we have 42 as our temporary rank of 3, and 3 as a final rank still. And then we have 41 as 41 centimeter and temporary rank of 4 and final rank of 4. And then we have 40 centimeter. For the temporary rank, we have 5, and for the final rank, we have 5.5. And for the next one, we have still 40 centimeter, and for the temporary rank, we have 6, and our final rank is 5.5. Again, since it has the same centimeter in length, 40 centimeters, so that is why we put 5.5 for both watermelons in length, and so on and so forth. And okay, for our last, for our Spearman raw computation, as you can see there in your screen, for our formula, we have RS, or a Spearman raw, is equal to 1 minus 6 for the summation 6 multiplied to summation of d squared over n cubed minus n. So for the given, we have the summation of d squared is equal to 124, and for our n, we have 15. So Spearman raw, okay, in this case, you are going to distribute or given into the formula. For Spearman raw is equal to 1 minus 6 multiplied by 124 over 15 cube minus 15. Spearman raw is equal to 1 minus 744, since 6 times 124 is equal to 744 over 375 minus 15 is equal to 3,375 minus 15 is equal to 3,360. So next we have Spearman raw is equal to 1 minus 0.22142857142. And for the last process, we have Spearman raw is equal to 0.7785 or 0.78, since 7785 round off to since 778 and 8 is above 5, so we need to round off the 7 into 8. So we have the final answer of 0.78, which denotes as a high relationship. Okay, for the last part of my report, as you can see that there's a graph, and for our y-axis, we have the length of our watermelon, and for our x-axis, we have the weight of our watermelon. So for our y, or for the length of watermelon, as you can see, I put 5 10, 15, 20, up to 50. So the class interval, or the interval of my y is, or our y in the graph, is only 5. And for our x, as you can see there, 110, 130, 150, up to 290. So I put in our graph for x 20 as the interval in our graph for our x. So as you can see there, we are just going to start for our graph, or for our point, which is the 110 and 20. So we are just going to find 110 and 20 and put a dot in the middle of both number, from x as 110 and 20 as our y. And then we have here the next one, 115. So you're just going to find 115 in our x and 20 in our y. And then 135 in our x and then 22 in our y. Put a dot. And then 142 and 142 in our x and 24 in our y. So again, put a dot on it. And 142 still in our x and 25 in our y. So above of it, so we're just going to put a dot. And then 150 in our x and 27 in our y. And then 175 in our x and then 28 in our y, so put a dot. And then 180 in our x and 30 in our y. 185, so we are just looking for 185 in our x and then 35 in our y, so we are just going to put a dot. And then 190 in our x and 40 in our y. And then we're just going to find again for 200 in our x and 40 in our y. And 220 again for our x and 41 in our y. And 220 in our x again and 42 above of it in our y. And 230 in our x and 45 in our y. And for the last dot, we have 280 and 40 in our x and 47 in our y. So that is the highest point in this graph. So you're just going to draw a line to connect the dot, and that is our graph. So that is my report, guys, about the Spearman raw computation between the weight, which is our x, and our length, which is our y. And I hope that you learned something about this report. And please don't forget to answer my formative quiz after watching my video. I hope that you're doing good there, and stay safe, everyone, and God bless.